Hello, welcome to another online lecture on network security. And in today's network security lecture, we are going to be focusing on the topic of transport level security. So, in the previous weeks, we have covered the basics of network security, and also we briefly touched upon network access control. And in today's lecture, our focus will be on transport level security and why that is necessary and what are some of the different methods and mechanisms that we can use to establish transport level security. To start thinking about transport level security, we have to start thinking about what is the most common type of network traffic that we would encounter, particularly when thinking about the internet as the network. In that case, World Wide Web or the web traffic can be considered as one of the predominant types of network traffic that can be happening, and in many ways it is essentially a client server application running over TCP IP connections or internet connections. So the client in that connection or in that service would be the users who are using browsing something on the internet and on the World Wide Web, and on the other end the servers are from whichever website we are using through World Wide Web. And the main sort of concern or main concern from a security perspective comes from how and why web is being used and what are some of the ways it is being managed, used, and so on. So when we think about a web server, it is a fairly easy thing to set up without needing high level of technical know-how. So we can set up a web server without much difficulty. Then similarly, any content on the web can also be easily available, particularly with the tools and techniques that are available at present day with many sort of online based tools and a variety of tools and things like that. It is also fairly easy to put out content through the World Wide Web. But the underlying software, the underlying web server softwares, and the underlying, say, for example, the client server software, the web browsers are fairly complex to cater to the type of communications and traffic that we have on World Wide Web. And because they are fairly complex software, they can also have somewhat complex security architectures, and then which in turn leading to potential security flaws. Because of the complexity of these systems, there are potential for security flaws. So one of the main concerns from a network security point of view is, particularly from the point of view of an organization, is if there is a vulnerability on the web server, for example, and if that vulnerability can be reached through standard web traffic in that case, then that part of the web server can be used as an entry point to gain access into the various other parts of the internal network. So from a corporate's point of view, that is a significant concern. So if you are an organization and you have an outward facing website, a web server that is connected to the internet, and so you would accept and users are allowed to access that resource, but then that server may also be connected to some of the backend services, internal networks of the organization. Then if some of these vulnerabilities are exploited and then they can reach the backend of the network, is a concern for many organizations. And one of the other concerns is the nature of users that we would have interacting with these services. Again, thinking about a lot of casual untrained, particularly untrained around security matters, such users are the most common users of these web based services. And then, because of their lack of understanding about security practices, security systems, there can be issues that can lead to certain systems being exploited by way of these users. So, this is also another concern when considering security, particularly web security, from a point of view of an organization. So, when we think about the type of threats and what are some of the consequences and also countermeasures that we can have, particularly in the case of web, for example, uh, we may start with the example of integrity. So, these are some of the basic uh, properties that we have previously discussed as well. So, if we when we think about integrity, for example, this is where the user data is modified without consent. So then these could happen in many different ways: modification of user data using Trojan horses that are appearing in web browsers. So again, it and at one or the other end of the network traffic, the communication in the web, there can be integrity based attacks happening. Threats are potential in those ends. And if that happens, if a vulnerability of such nature is exploited, then it can lead to significant loss of information, compromise of the services, and overall the integrity is compromised. And as a countermeasure, the basic countermeasure, we may use what are called cryptographic checksums. So these are sort of common methods that can be used as countermeasures in case of integrity. So similarly, confidentiality, we don't want information to be exposed to people that we don't want them to. And threats can be people listening in on the traffic from the client side, from the server side, sometimes even knowing the information about the network configurations, clients and servers, and who are talking to each other. Even if you cannot intercept the traffic itself, just the fact that there are some parties are communicating can be interesting or useful information to some third parties. So again, this could lead to loss of information, loss of privacy, and one of the sort of couple of the common countermeasures are using certain encryption mechanisms or using web proxies and so on. Then, when we think about denial of service type threats or attacks, again here disabling users from accessing particular servers, or if there's a vulnerability on the server side, and it can compromise users being able to create new requests, or if other services are launching a lot of flooding with a lot of requests and not disabling other new users from sending requests. So again, typical DOS or DDoS type attacks, which can disrupt or even prevent users from doing something critical that needs to be done. And from a security point of view, this is one of the most difficult ones to prevent as well. So this is not very easy to prevent from an internal or like cryptographic, that type of mechanisms. You may have to have much more broader analysis tools and things like that. So this is again a very active research area even still to this date. Then another factor that can be compromised is regarding authentication of users or people who are trying to access these services. Again, people may impersonate other people and that can lead to forgery and so on. So again, this can lead to a number of misrepresentation of users or wrong information being disclosed. So it can lead to a number of serious consequences. And again, here we may use certain cryptographic techniques as countermeasures to counter these threats. So when we think about traffic or communication, when we when we are thinking web traffic, for example, there are traffic or communication happening at various layers. So if we take a communication between two entities, it can be, let's say, it's host A to host B, or one, say, for example, host A could be the client and host B could be the server. And if we take that as the web traffic that is happening, so and there could be a number of intermediary routers through which network traffic has to pass through. And in that case, at the bottom data link layer, the communication is between each of these entities. So the host to the router, router to the next router, and so on, and then to the final host. The same thing would also happen at the network layer, again, communication between each of these nodes. But when we think at the transport layer, there it is significantly different here. So at the transport layer, the traffic is actually between the transport layer at the client and the host. That is not visible or not considered at the intermediary nodes of routers and so on. Similarly, the same thing applies to application layer as well. Again, it is end-to-end communication. So when we think about security and different security protocols that can be used in these environments, when we think about, say, network level, we would use things like IPsec, which we would be discussing sometime later in this course. Then at transport level, which we are discussing today, we may use SSL or TSL. Again, we will discuss about these later today. And then at an application level, we may use things like KBROS and like different authentication mechanisms and so on. So again, some of these things we may revisit at a later lecture in this course. But the main thing to remember here is there will be, again, different security mechanisms employed at different layers. So when we think about a multi-layered security architecture, we will have different security mechanisms employed at each of these layers, and all of them will fall back onto the next layer to still have some level of network security and overall infrastructure, computer infrastructure security in that environment. So let's get on to the main discussion topic for today's lesson, which is transport layer security, or TSL. So the transport layer security protocol is currently it is the de facto internet security protocol, and it is implemented in web browsers, web servers, and all the communication that is happening, all the web traffic, so to speak, is expected, or when we think about secure traffic, it is using TSL as the underlying security protocol. So mainly, say, whatever the secure traffic, when we say we are using secure communication in web, we are talking about secure traffic from a web server to a web client happening through TSL. And TSL itself is based on what is called Secure Sockets Layer Protocol, or SSL. So that is why we may have heard the terms SSL as well. Again, that used to be the standard protocol for a while, and now TSL has taken that place as the standard or the de facto standard for internet communications. Both SSL and TSL are largely similar because TSL itself is based on the SSL design, the protocol design, particularly the version 3 of SSL became the version 1 of TSL. So the protocol design is same, how the communication happening and all these things are same, but the main difference is the algorithms used, the cryptographic algorithms and so on used in both of these protocols are somewhat different. So when we think about all the web browsers, most of them, almost all of them employ or implement this transport layer security feature. So when we think about the history of SSL or history of these protocols, it started with SSL 1.0 in 94 within the Netscape browser. So it was part of the Netscape browser, and that's when the sort of the internet security or web security was first introduced. But the initial version was not that famous, so it was never. It's not. There are not much interesting thing happening with that. But then the SSL v2 was implemented again with Netscape, and it is a published one, so it is, you can look up that. But it had a lot of significant issues which were fixed in SSL v3, again mainly from Netscape and available from 96. But then SSL v3 was adapted into an open standard, an internet standard, as TSL or Transport Layer Security version 1. It was based on SSL v3, but it was not interoperable with SSL v3. That is because it uses different algorithms. So these two cannot interoperate between each other. So we cannot communicate between an SSL, a server running on SSL, and a browser trying to communicate through TSL would not work. Both parties should not use one or the other. And given TSL is now becoming or has become the main standard for these communications, SSL is no longer a key. The relevance is no longer so much. So when we think about TSL particularly, TSL, as we said, it is the most widely used security service, period. So web and all considered, that is the most widely used security service. And it was defined as part of what we call as the RFC, or request for comments. It was initially came up as that, and then one of the reasons for that is SSL was a commercial protocol because it came up with Netscape. It was a commercial product. It was TSL was the open standard or the internet standard to be implemented by everyone. And the main thing to remember is it is implemented by most browsers and other equipment, services, everything that is connecting to the internet. They are implementing TSL these days. So when we think about the TSL architecture, or the Transport Layer Security Protocol architecture, there are two main concepts that we would have here. So the first concept is what is called a TSL connection, and the second one is what is called a TSL session. So basically, a TSL connection is a connection between a client and a server. So two entities that are connected to each other is a connection. So any sort of communication connection, we will consider that as a TSL connection. But connections are considered transient or relatively temporary. So what that means is, if a connection is established between two parties, that connection may go off in a period of time. Say I am connected to a server, and while I am not using that connection continuously, that connection may be lost. But when we think about web services, a typical usage of a website, for example, let's think about a web-based email server like Gmail, for example. You log into Gmail. So initially you log in, the connectivity is established, so the first connection happens. But then now you are reading an email. While you are reading an email, it is possible that connection is no longer active, and After a while, maybe a few minutes later, the connection becomes active again, and you try to go to another page or another email. So now a new connection is established. But if the new connection is established, does it need to again check for everything relevant to that connection? Authenticating the users, checking for the communication, establishing all these connection related security aspects. Do they need to be checked again? That is the one that is will be managed by what is called the TSL session. So TSL session is the association or the connectivity between a client and a server, and it will be established by what is called a handshake protocol. We will discuss about this a bit later, and they will establish the cryptographic connections, parameters and so on necessary for those connections, and these parameters can be reused by a number of connections. So what we will do is we will first go and establish a session between these two entities. So if these are the two entities, we will say a session is established. Then once the session is established, we can have number of different connections happening few different times. So you connect and then disconnect and maybe again connect, but you can use the same cryptographic information again. So the main purpose of having sessions is we avoid the need to having to create new cryptographic connectivity parameters. Because of security requirements, what we need to do is to establish a connection, we have to establish certain cryptographic connectivity parameters. We will discuss about this in a bit more detail later on. To do that, it requires a lot of time and effort, and if we have to repeat that quite a lot every time it disconnects and reconnects, it will be a lot of waste of time and resources. That's why we would use the concept of session that can be somewhat permanent or more permanent than the concept of a connection. It can connect and disconnect, but the session can still be active or valid. So when we think about connections and connection states, there are a number of common parameters that we can identify related to connection. So the server and client random is a byte sequences that are normally used for each connection. So for each connection that is established, so that is there will be some random strings or random parameters that will be used there. Then server write MAC secret is again the secret key for MAC operations on the sent by the server side. So similarly, there will be a MAC secret on the client side, and then there will be a server write key and a client write key. So again, we will look at these parameters and how they operate a bit later on. And in addition to that, we will have initialization vectors and sequence numbers. Again, they will be used when we are establishing connections using TSL, which we can discuss a bit later on. Then similarly, for each session, we would have what is called the session identifier, peer certificates, compression methods, cipher spec, master secret, and whether the session is resumable or not. Particularly this, whether session is resumable or not, is an interesting parameter, particularly considering if we want to allow new connections, to be established, then we should have the flag indicating that new connections are allowed or the session can be resumed. So that is the main aspect, of the main parameter of a session that is relevant to having more connections. So if you want to establish multiple connections within the same session, then we should have the is resumable set to active. Then master secret is also another important parameter here, which is the main sort of cryptographic secret that is shared between the client and the server, and this is the one that will be used for uh, maintaining a secure communication. So this is also an important part of this session state parameters. So when we think about the TSL protocol and the TSL protocol stack, it uses two layers of protocols as part of the overall protocol itself. So basically, where it starts would be the IP layer. So the IP layer and the TCP layer. So these two will be there as part of existing protocols on the communication that is happening there. Then above that, we have what is called the record protocol, and in addition to that, it also has another set of protocols such as the handshake protocol, change cipherspec protocol, alert protocol, heartbeat protocol, and so on. So, and along with this, we can have any sort of upper layer protocol such as HTTP or any other upper layer protocols can also be there at that level. So that all of these together can be considered as the TSL protocol stack. The main purpose of having these protocols is having a reliable end-to-end transfer by using TCP. So that is one thing. So we need to have a TCP connection, TCP IP connection, and then these protocols add the security features on top of that. So these two layers of protocols combined together is considered as what the TSL protocol stack is. The first layer of the protocol in TSL is what is called the TSL record protocol, and the main purpose of the TSL record protocol is twofold. One is providing confidentiality, and the other one is providing message integrity. So, as we said, the two main requirements, two of the main requirements of web security, for example, confidentiality and integrity, and the record protocol provides both of these. It provides a confidentiality using implemented using as part of the handshake protocol. It creates a shared key, and that is used to implement standard encryptions to provide or encrypt the TSL payloads. So any of the standard encryption algorithms can be used there. Then for message integrity, again, the handshake protocol would define the shared key, and that can be used as part of message authentication code MAC, and using HMAC and the shared key, message integrity can be ensured. Again, message authentication codes, hash keys, and similar things you might have covered in the previous security course. So when we think about the TSL record protocol, what happens is, so when a communication happens within TSL, it would start with the application data. So whatever the application data would start from the application. So that is the application data that we are having coming out from the application. Then that application data will have to be fragmented into number of pieces. So again, whatever the application data, we'll have to break that down into smaller chunks. So these TSL record protocol operation can be performed on each of those chunks. Then optionally, one of the things that can happen here is a compression. So compression can be happening. Again, the size of the fragment can be reduced using compression, but compression can be optional. Then after that, the message authentication code or the MAC can be added for the message. So whatever the fragment message fragment that we receive from above, the MAC can be added to that. Then once that is added, the next stage would be to encrypt. So whatever the message there would be encrypted here. Then after encryption, it can add the TSL record headers. So TSL record headers can be added after encryption. So that is the basic format of or basic operation of TSL protocol. So TSL record protocol, this is the way that it creates a record for the purpose of communication. So in addition to the TSL header, the TSL record header, rest of the entities will be fully encrypted. So only the header is something that it would be visible as part of the record. Within the TSL record protocol payloads, we can have indication of we can have different payloads depending on the protocol message that is there. So we can have change cipherspec protocol, alert protocol, handshake protocol, and any other upper protocols about that. So again, if you go back to the protocol stack, the record protocol will be at the bottom. So the record protocol will be at the bottom, and on top of that, we can have these other protocols. So now let's look at each of these in a bit more detail. So the change cipher spec protocol is basically a simple protocol. The main idea is to establish or to inform that new handshake protocol needs to be performed. So it is to say a cipher communication needs to be established. So it is just indicating the necessity to do that. So it is a single command, establish the send back and forth between the client and server to indicate that they need to do the handshake, and it will be mainly used as part of the handshake protocol. Then the alert protocol is basically to alert or convey TSL alerts to any peer entities. So again, it can be the messages, or it can be a two-part message. One is called the severity level, or the severity of the security level, and it can be a warning message, warning alert, or a fatal alert. A warning could be relevant to the connection that can resume, and if it is a fatal, it means the connection is terminated. And then additionally, there can be an alert code that would say unexpected message, bad MAC record, decompression failure. Say, for example, if a communication is established between a client and server, and when the message is received at the other end and there's an issue with decompressing the received message, then it may send back an alert saying there is a decompression failure. So there could be other issues like handshake failures, illegal parameters. So if there are other people intercepting the traffic, again, this may lead to some of these alerts being produced. So alert protocol, the main functionality is for the both parties engaging in the communication to communicate additional information relevant to the communication. So again, this is not about the actual communicating the actual information. This is about the connection and the session, and are there any issues relevant to that. So this is mainly to convey or communicate such information. Then handshake protocol is the main or one of the key protocols as part of TLS. So it is the one that is going to establish the connectivity, establish the secure connectivity between the client and the server, between the two peers. So as part of the handshake protocol, there are a number of important things happen. One is it would authenticate. So authentication is one of the main things. Then negotiating the encryption and MAC algorithms. So if two parties are communicating, they have to agree on a particular encryption algorithm for the encryption purposes and message authentication code purposes. So again, we need to have an agreed algorithm. So again, this handshake protocol would establish that. Then also, to have secure communication, there should be agreed upon cryptographic keys. So again, those cryptographic keys is also provided or managed through the handshake protocol. Then by doing all of these things, we can see the handshake protocol as the one that is actually establishing the secure connection. So it will establish a session and then in turn a connection which is secure. So the handshake protocol has to be done before any data transmission or data transfer can start. So we cannot start a secure record protocol or secure record protocol communication before a handshake protocol has established the secure communication. So we can see the handshake communication, the handshake protocol in 4 major steps as illustrated in this diagram. So the first one is establishing the security capabilities. The second phase is server authentication and key exchange. The third phase is the client authentication and key exchange, and the fourth phase is where we finish the establishment of this secure communication. So the handshake protocol messages are fairly simple. They would specify what is the type of the message and the length of the message and whatever the content that is included as part of the message. So it is a fairly simple message format. So in terms of the types of message that can be sent, again there can be hello messages. So a hello request, client hello, server hello, certificate, server key exchange, certificate requests, server done, certificate verify, client key exchange, and finished. Again, as you can see, these are the type of messages that are used as part of these communications. We will look at each of these in a bit more detail as part of the four-phase communication as part of the TSL handshake protocol. So when we think about the first phase of the handshake protocol, only 2 things happen. The client would send a client hello and server would send back a server hello. But what we can see is with the client hello and server hello, it can also include the version, the random IDs, session IDs, and also the cipher suit and compression method. The cipher suit would specify, cipher suit and compression method, both of them would specify which algorithms should be used. So by sending the client hello, client would send the specific cipher suit, compression method, and so on. Similarly, server would also send back the particular cipher suit and compression method there. So the phase 1 is mainly about establishing the basic capabilities that are necessary to further establish secure communication. Then at the second level, it is all about server sending its authentication and key information. So the server would send the certificate, a key exchange, and it may also request for a certificate from the client, and it will complete that communication by saying server hello done. So that is completing that phase all its own. Then once the server has ended its communication, then client can respond back with its certificate if the certificate was requested, and then client can send its key exchange, and client may also send a certificate verification. That is phase 3 of the handshake protocol, the client authentication and key exchange. In the fourth phase is where the cipher suit is changed and handshake protocol is completed. So client would send the change cipher spec and finish the establishment of the handshake, and similarly the server would send back the send a change cipher spec and finish the establishment of the handshake. So that fourth stage or four-phase establishment of connection would result in having a secure communication channel established, through which further communication can be done. One of the things that we can see here is it is a fairly lengthy affair in terms of number of messages exchanging between when this handshake is happening. And given handshake is the main protocol that needs to be established for any secure communication, it will have to happen. But one of the things that we can see is if we are using the same session across number of connections, then we may not need to repeat a number of these steps every time. So for example, we can have what is called an abbreviated handshake, and with abbreviated handshake, what we can do is in phase 1, both parties can agree upon a session ID, and if that session ID is already agreed upon and already a session is established for that, we can skip the phase 2 and phase 3 where the key exchange and authentication and key exchange happens. So those things can be skipped because we already have an established session. So we are using that session. So we do the phase 1 to say this is the session that we are using, and if that is agreed upon, we can go to phase 4 and complete the handshake. So phase 2 and phase 3 can be skipped in an abbreviated handshake. One of the main things that would happen when we are establishing a TSL communication, a secure TSL communication, is the computation of cryptographic parameters. So the main secret that will be computed is what is called the master secret or the shared master secret, which is a 48-byte value that is generated for each session. So for each session with a secure key exchange, we create what is called a shared a master secret, and this is what will be used for all the secure communication between both the client and the server. So any other further cryptographic parameters will be used or will be generated from the master secret. So the master secret would be the overarching one for the particular session. So as part of using master secret, there will be a number of different cryptographic parameters will be generated. So master secret is the main cryptographic key, for example, that will be available, and using that a number of additional cipher specs will be created. One is client write max secret, server write max secret, client write key, server write key, and so on. So these will be generated as part of a set of cryptographic parameters. Then the last protocol that we would have as part of the TSL protocol set of TSL protocols is the heartbeat protocol. So the purpose of the heartbeat protocol is mainly to make sure uh, the a message is sent from a sender to a receiver to ensure that connection is active and the other party is still actively connected. So it is basically a stay alive connect message. So it can be used for a number of reasons. One is to see if the network connectivity is still active, and also what can happen is in sometimes the communication can be sporadic. So, for example, you may send a message and receive a reply, and then you may wait for a bit and then send a message after a while. During that time, that connection should not be closed. Sometimes firewalls and such can close idle connections. So by sending these heartbeat messages, the heartbeat protocol can ensure that the connection is always kept alive. So again, heartbeat protocol runs on top of the TSL record protocol, and uh, it has two messages. One is called the heartbeat request and the heartbeat response. So if you may send, one entity may send a heartbeat request and the other entity may respond with a heartbeat response. So the heartbeat protocol is necessary to establish uh, 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 it is established during the phase one of the handshake protocol. And also one of the other relevant aspect to heartbeat protocol is the uh, sort of a variation of what is called TSL is what is called the datagram transport layer security, or TALS, and there are again a variation connectionless version of TSL. Again, heartbeat protocol can be supported there as well. So now let's think about what are some of the different attacks that can happen, or that can be targeted on SSL or TSL protocol. So we can categorize these attacks into sort of a few categories. One is the attacks that are targeted on the handshake protocol itself. So if there is a way to intercept the handshake protocol and then establish the connection as sort of the man in the middle kind of a situation. So if a handshake is happening between two entities, if an entity can come in between and then intercept that and still establish a form of a connection between these two entities, so then that could be a form of an attack. Then there can be other attacks on the record protocol or other application data protocols. There can be attacks on the public key infrastructure itself. So the underlying public key user, because the cryptographic public keys, and if there are any vulnerabilities in those, attacks can be on that. And then there can be some other attacks using the various applications and other vulnerabilities relevant to how these are implemented and used. The reality of the nature of network security and computer security in general is there is going to be a back and forth between these threats and countermeasures as things evolve, as internet based protocols evolve. There will be new threats coming along, and there will be new countermeasures to address those threats. So that is the nature of this environment, and the same thing applies to TSL attacks threats as well. The latest version of TSL that is currently being used or commonly being used is what is called TSL version 1.3, and the main purpose of this is improving security, and it has a significant changes from version 1.2. Uh, it removes a number of aspects, particularly things like compressions, ciphers that do not offer authenticated encryption, static RSA and DHO Diffie-Hellman key exchanges, and so on. So, a number of in these features that were there in the previous versions are removed. And particularly with TSL 1.3, it does not allow RSA. You cannot use RSA for key exchange. You have to use either Diffie-Hellman or elliptic curve Diffie-Hellman for key exchanges. And also TSL 1.3 again allows for one round trip time handshake by changing the order of messages are sent with establishing a secure connection. So again, there's a slight difference in the way the handshake protocol would operate in TSL 1.3 compared to the one that we covered previously. Then, when it comes to web traffic, one of the ways that we use TSL and SSL for that matter is what is called HTTP over SSL or TSL, and which we normally identify as HTTPS. So, it is basically using the web communication between the web servers. The application are the web services, or rather the web server and the browser, and it is done through a SSL or a TSL communication. So main ways that we would identify is using the URLs for communication are HTTPS, and also the port that is used is different as well, and particularly we would use, and currently it is the expectation is almost all websites on the internet are using or expected to use some form of encryption, particularly the ones that have critical information, sensitive information. So again, this is very commonly you would find in many applications, many web applications and so on, websites and so on. So HTTPS is the implementation for web communication or web traffic using TSL or SSL. So for an HTTPS connection to be established, it has to do two things. One is it has to initially, the HTTP client, so that would be the browser, has to initially connect to the server. So it has to initiate the connection, and then it can initiate the TSL client hello to initiate the TSL handshake. Then once the TSL handshake is completed, whatever the HTTP data that will be sent as part of the TSL application data. Then it will be put in the TSL record protocol, and it will be sent through the TSL protocol stack, or rather TSL protocol. Again, from a protocol point of view, again, given it is a multi-level or a multi-layer structure, so there will be three levels of communication happening. One is at the HTTP level, the communication between the client and the server, the web browser and the web server, and then at the TSL level, where the sessions are established between the TSL client and the TSL server, and then underlying the TCP connection between the TCP entities at the client end and the server end. So The HTTPS connection or the secure HTTP connection, it will be established uh, using a TCP underlying TCP connection, on top of which there will be a TSL session established, and on top of which the HTTP connection can happen. One of the important things about the HTTPS connection is the requirement to use a connection close, indicating a connection close when a connection needs to be closed. Otherwise, what could be assumed is it could be seen as an attack or evidence of an attack. So for that reason, to avoid security warnings and such, any sort of HTTPS connections that were established using TSL have to be specifically closed and before the connection is disconnected. Another protocol that is also relevant to transport layer security is what is called the secure shell. And this is again something that we have covered previously in the previous course as well, in distributed networks, in advanced network, and few of those courses we have covered SSH. The basic idea is it is a way to provide remote connectivity to it is a remote client login feature, similar to Telnet, but replacing Telnet as a more secure implementation. So the main thing is it can provide remote login facility, but in a more secure implementation. And these days SSH has become the standard used for connecting to remote servers, and also even to connect to other network equipment, routers, switches. You can connect and connect to the maintenance or consoles through SSH as well. Again, when we consider the SSH protocol, it is similar to the TLS protocol, but again, it is running on top of an IP network, on top of the TCP protocol. There, it has three protocols as part of the SSH protocol stack: the SSH transport layer protocol, and the SSH user authentication protocol, and the SSH connection protocol. So the SSH transport layer protocol basically establishes the connectivity between the client and the server. So that is the SSH transport layer protocol. So it basically establishes the TCP connection, and it does the secure key exchanges. So initially, when a secure connection or SSH connection needs to be established, it has to initially establish a TCP connection. Then after this, it has to exchange the keys, secure keys, and then it can start the communication. The SSH connection protocol is about the establishing of the it run on top of the transport layer protocol, and it is the one that is going to establish the authenticated after the authenticated transport layer protocol is connection is established. This is the one that is going to create a secure communication channel and do the secure communication as part of that. So the secure data transfer is the main purpose of the SSH connection protocol. So again, between the client and server, after the transport layer connection is established, it will open a new communication channel, do any of the data transfers, and that channel can be later closed. Then on the SSH user authentication protocol, this is regarding authenticating a client to a server, and this can be done using a number of different authentication methods, either using public key, crypto public key authentication, so having a private key and a public key and exchanging the keys between the client and the server. Authentication can be established like that. There can be password based authentication or even host based authentication. And the main three messages relevant to SSH user authentication protocol are the user authentication request, failure, or success. Then, when we are using SSH, one of the most useful features is what is called port forwarding. And the use of port forwarding is to convert any sort of insecure TCP connections into an SSH connection. This is also referred to as SSH tunneling. So what we may have is, say for example, we have an application that is producing insecure HTTP communication. But then what we can do is we can establish a SSH tunnel and send all the traffic through the SSH tunnel, and at the other end again it can be converted back into the whatever the application that it used to be. So the application can use a different port number, for example, and establish the tunnel, and at the other end it can be received back or converted back into whatever the necessary communication as needed. So that concludes our discussion into transport layer security. So one of the main reasons why we need transport layer security is particularly web traffic or many of the other traffic that can be done over the internet have certain security implications, considerations, and one of the ways that can be addressed is using transport layer security. And we can use either SSL or TSL to implement a transport layer security. Then when we use that as part of web communication, we use HTTPS is the implementation that is carrying transport layer security. Say for example, if we will establish a TCP connection, on top of it we will have a TSL communication, and on top of it we can have a HTTP communication, which will be the HTTPS. Then in addition to this, we can also have a secure shell communication, particularly for the purpose of remote login, remote communication to servers and so on. So again, that is also something relevant to transport layer security. So with that, our discussion concludes for today. We may look at another topic in network security next week. And in the meantime, there may be some quizzes and assignments coming up in the weeks, but details of those will be published on LMS. If you have any questions on the things that were covered in today's lesson or any other lessons, as always, you can contact me using the usual communication channels. And until next time, thank you for joining in today's lesson. See you. Bye.